Hey guys, I finally finished the Grand Calibrator rejuvenation, the formal part at least. Meaning I replaced the last few electrolytic caps and suicidal carbon composition resistors. It took a while, believe it or not. But it feels very good to finally be able to leave that thing powered on for extended periods of time, with minimal chances of something giving up its reddish ghost. Reddish ghost coming out right here, just in case that needed an explanation. I'm not quite sure who's more trustworthy now. Keithley 2001, whose calibration has been overdue since November 1996, or a freshly recapped, not warmed up Fluke 5700. But since all functions and ranges seem to be pretty much spot on, I think they are both doing pretty well for themselves. Fluke is actually drawing 160 watt continuously, in idle and in most operational states. One can effortlessly feel it heating up the tiny 4 or 5 square meter room it's currently in. I'm using this room for 3D printers mostly, and all of them like elevated temperatures. So in a way it assisted the SLA printing of its own front handles. I'm not sure yet if I want to leave it powered on 24/7. That would add €500 to my electricity bill per year. But for stability's sake, it would probably be best practice. I've been warned that there may also be some more subtle problems that don't show up in the self-test programs. Like, for example, ever so slightly worn out relays or incorrect oven temperatures that cause ppm level offsets. Wouldn't mind investigating something like that at all, because so far all I've been able to do was some general purpose electronic repair handiwork. Still, I've got about 160 GB worth of raw footage to make an epic video from. And Transmill seems to be willing to send over a demo unit of a very interesting 8.5 digit voltmeter for a month or two. That way we could verify success or lack thereof a little bit better. I've also planned a few other amateurish metrology projects for the next few months, which would benefit from such a multimeter. But until then, something slightly different. Do you remember this collection of short wavelength light bulbs that we looked at last year? For various reasons I've taken them all apart, except for this one. I thought this skin-colored, hip-shaped X-ray head with an erect filter aperture protruding from it to make matters worse was very amusing. And it sounded like the tube was shattered anyway. Well, I think the amusement is worn off, and I've shown the thing to all friends at least twice now, so it's gotta go. See that oil stain on the carpet over there where the CNC machine used to stand? No, me neither. I cleaned that up so nicely, but I think I'll use that particular spot to open up this oil vessel from the 70s. It's a 600 watt X-ray emitter made by Ritter in Karlsruhe. And it's built entirely differently than I had expected. Only that top part with the transformer seems to be filled with oil. Then there are 2 high voltage feed-throughs coming from that compartment and going to what looks like a Bakelite tube holder. So far I haven't met any glass shards in here, but some very loose washers underneath this heatsink. I think those are what caused the misleading rattling. To prevent radiation from escaping into all directions, the tube itself is kept in another lead pipe with a small axial hole. And it's actually intact, I had no idea. It's a long boy, but completely conventional. Meaning that it uses a hot cathode to bombard the high voltage anode with electrons, on impact of which X-rays are emitted. The Germans call that Bremsstrahlung. High voltages in X-ray systems usually meaning 30 to 100 kV. With a powerful transformer backing up such a high voltage, there's a good likelihood of death on contact. Cable isolation or silicone gloves wouldn't stand a chance. I'm using a 1 gigaohm resistor in series with my DMM's 10 megaohm input impedance to form a voltage divider and measure approximately 1% of the overall voltage. This strange transformer was apparently wired for 70 VAC in, 100 kV out. Now, it's still illegal to emit X-rays as an untrained individual, for good reason I might add. Others have already made that sacrifice to demonstrate it to a satisfying degree. So I'm not going to show anything spicy here. I can, however, show how I would prepare if I ever decided to make an X-ray exposure at home. My DNA is okay the way it is, so I'm going to try and wear this pink, 2 sizes too small lead apron that has been donated by Gigabecquerel. All the conventional X-ray tubes we've salvaged are also okay the way they are, for looking into naturally unprecise organisms like humans. They are, however, unsuitable for more interesting stuff. Because they are not perfect point sources, they can only cast blurry shadows. Which is no fun when trying to look at PCB features, for example. A solution is to use an unconventional tube, a so-called Microfocus Source. It uses an electrostatic Wenelt cup to influence the beam in such a way that a small diameter crossover point forms, which can then, under ideal circumstances, be focused directly on a target and become the point source that we wanted. Getting hold of such a tube is very difficult and expensive. Luckily, Spirit had a spare part from this cute machine, which he was able to sell me. Just the bare tube, with its filament, high voltage, and electrostatic Wenelt cup pins on one side, and a ridiculously thin and fragile beryllium window on its nozzle. Woohoo, even more danger points for this whole endeavor. In spite of having some qualified help, the medical image sensor was the hardest part to figure out. If you haven't seen that last Patreon video where we took one apart, you've got to check it out. It's a piece of beauty. The command processor connects to the actual image sensor with a custom LEMO connector cable, for which I just butchered a USB cable with nice wire mesh shielding, and a not so custom duplex fiber link, acceptance of which being indicated by those LEDs turning green. The sensor is capable of 25 frames per second at 1024 by 1024 resolution and 14-bit depth. That's a lot of data. There are a few options for a PC interface. I'm just going to go with the easiest one, a crossover cable. The first one I had to crimp in like 20 years or so. Kids these days don't even know those anymore, because modern NICs should be able to detect pinouts automatically. I've got a bit more info about this digital imaging system. If anybody happens to find one of their own, send me a message. Maybe I can hook you up with a driver or something. But it's too boring, and too secret actually, for this story. So I'm jumping right ahead to my favorite part, where I'm floating a Miniware MDP XP power supply and its brave little USB power bank at 100 kilovolt, while adjusting the filament current wirelessly from a distance with that remote control slice that looked so silly at first. My makeshift setup is hissing because of corona discharges. Those were cool a long time before the whole corona trend started. Now the filament begins to glow at around 3.7 ampere. X-ray emissions would start soon after, and then we could actually grab a frame from the image sensor. If that was legal, I mean. Here's a random X-ray image I found on the internet. Looks to me like a Geiger-Müller tube hanging in front of the sensor, but no way to be sure. Must be a beginner though, because the operator didn't do offset calibration before starting the exposure. Another such random image from the internet. It could be a circuit board this time, but again, all parameters all over the place. It's understandable, honestly, because there are a ton of parameters that can be tweaked in the right or wrong direction. Here's the last image I found in that session. It's obviously a circuit board. It's getting somewhere, but maybe their high voltage was too low this time. Because there's barely any penetration, except for the via holes. I'll look harder and keep you updated if I find any more interesting X-ray images on the internet.